Welcome to our SQL tutorial series. In this first video, we'll be diving into the basics. So, what exactly is a SQL? SQL stands for Structured Query Language. It's a powerful tool used to manage and manipulate databases. Whether you're working with small data sets or massive enterprise-level databases, SQL is the go-to language. Throughout this series, we'll cover everything from basic queries to complex data manipulation. Let's get started. Step 1. Install SQL Server Management Studio, SSMS. Download SSMS. Go to the SQL Server Management Studio download page. Click Download SQL Server Management Studio. Run the installer. Pause. Run the downloaded file, SSMS setup.enu.exe. Follow the on-screen instructions to complete the installation. Step 2. Connect to SQL Server. Launch SSMS. Open SQL Server Management Studio from the Start menu. Connect to Server. In the Connect to Server window, server type, database engine server name, localhost, or .SQL Express for a local default instance. For named instances, use localhost instance name. Authentication, choose Windows Authentication or SQL Server Authentication, depending on your setup. Click Connect. Explore SQL Server. You are now connected to SQL Server and can start creating databases, running queries, and managing your SQL Server instance. Understanding databases and tables. Now that our environment is set up, let's talk about databases and tables. Think of a database as a collection of related data, and tables as the organized structures within that database. In SQL, we interact with tables to store, retrieve, and manipulate data. Let's create our first database and table. Image showing a visual representation of a database with interconnected tables. The tables are represented as grids with rows and columns, with data flowing between them. Create database, my first database. Use my first database. Create table employees. ID int auto increment primary key, name varchar 100, position varchar 100, salary decimal 2. This video introduces the core concepts of databases and tables, which are crucial for understanding how SQL works. The sample code demonstrates the creation of a simple database and a table. Learn how to insert data into SQL tables and understand the structure of SQL insert statements. With our table in place, it's time to start adding data. In SQL, we use the insert statement to add records to our tables. Let's add some sample data to our employees table. This video covers the process of inserting data into SQL tables, which is fundamental for building a database. The sample code illustrates how to add multiple records in a single query. Insert into employees, name, position, salary. Values, John Doe, manager, $75,000. Jane Smith, developer, $65,000. Emily Davis, designer, $60,000. Now that we have data in our table, it's time to retrieve it. The select statement is used to query data from a database. Let's see how it works. A computer screen displaying a simple SQL query using the select statement, with the output showing the results in a tabular format. Sample code, select from employees. Learn how to filter your query results in SQL using the where clause, an essential tool for data retrieval. Not every query needs to return all the data in a table. The where clause allows us to filter our results based on specific conditions. Let's say we want to find all employees with a salary above $60,000. Here's how we do it. Explanation. This video explains how to refine SQL queries using the where clause, which is crucial for extracting specific data from a database. The sample code demonstrates a simple filtering operation. Once we've filtered our data, we might want to sort it. The order by clause lets us sort our query results based on one or more columns. Let's sort our employees by salary in descending order. This video covers the SQL query with an order by clause, sorting data in a table by salary. The output shows the data ordered from highest to lowest salary. Select from employees, order by salary des, Explore SQL's aggregate functions like count, sum, AVG, min, and max, which allow you to perform calculations on your data. Let's calculate the average salary of our employees using the AVG function. This video covers aggregate functions in SQL, which are essential for performing calculations on data. The sample code demonstrates how to calculate the average salary of employees. Select AVG salary as average salary from employees. The group by clause is used to group rows that share a common value into summary rows, like finding the total salary by department. Let's group our employees by position and calculate the total salary for each group. This video introduces the group by clause, which is crucial for grouping data in SQL. The sample code shows how to group employees by position and calculate the total salary for each group. Select Position, Sum Salary, AS Total Salary from Employees Group by Position. After grouping data, we might want to filter those groups. The having clause works like where, but it's used for groups rather than individual rows. Let's find the positions with a total salary greater than $120,000. This video explains the having clause, which is used to filter group data in SQL. The sample code demonstrates filtering positions based on their total salary. Select Position, Salary, AS Total Salary from Employees Group by Position, having total salary $12,000. Welcome back to another video. To understand joins, let's create tables and insert data first. Following images will show new tables and data. An inner join returns only the rows that have matching values in both tables. If a row in either table does not have a matching row in the other table, that row will not be included in the result. Here, Department ID column is common in both tables to join the tables. Inner join query. Select employees.name, employees.position, departments.department_name from employees, inner join departments on employees.department_id equals departments.id. Refer attached output image and next video for query execution. The left join clause is similar to inner join, but it includes all records from the left table, even if there's no match in the right table. Let's see this in action by joining our employees and departments tables. This video introduces the left join clause, which is useful for handling missing data in SQL. The sample code demonstrates how to include all records from the left table, regardless of matches. Select employees.name, employees.position, departments.department_name from employees left, join departments on employees.department_id equals departments.id. The right join clause is similar to inner join, but it includes all records from the right table, even if there's no match in the left table. Let's see this in action by joining our employees and departments tables. This video introduces the right join clause, which is useful for handling missing data in SQL. The sample code demonstrates how to include all records from the right table, regardless of matches. Right join query, select employees.name, employees.position, departments.department_name from employees right, join departments on employees.department_id equals departments.id. A full outer join returns all rows when there is a match in either table. If there is no match, the result set will contain null for the columns where there is no match. Note, some SQL databases do not support full outer join directly, but you can achieve the same result using a combination of left join and right join with a union. Select employees.name, employees.position, departments.department_name from employees full outer join departments on employees.department_id equals departments.id. Order by employees.name. Subqueries, also known as nested queries or inner queries, are queries that are embedded within another SQL query. They are used to perform operations that require multiple steps, such as filtering, aggregating, or comparing data across multiple tables. A subquery is typically placed within a select, from, where, or having clause of another query. Let's explore subqueries using the employees and departments tables that we created earlier. In this example, we'll find the highest salary in the employees table and display the name of the employee who earns that salary. Select Name Salary from Employees, where salary equals select max salary from employees. Explanation. The subquery, select max salary from employees, finds the highest salary in the employees table. The main query then selects the name and salary of the employee S, whose salary matches this highest value. Result. In this example, suppose we want to find the names of employees who work in the engineering department. Select Name from Employees, where departments where ID equals select ID from departments where department name equals engineering. Explanation. The subquery, select ID from departments where department name equals engineering, retrieves the ID of the engineering department. The main query then selects the names of employees whose department ID matches this value. A SQL view is a virtual table that is based on the result set of a SQL query. Unlike a physical table, a view does not store data itself. Instead, it dynamically generates the data from the base tables whenever the view is accessed. Views can simplify complex queries, provide a layer of abstraction, and enhance security by restricting access to specific data. Why use views? Simplification. Views can simplify complex queries by encapsulating them within a single object. Security. Views can be used to expose only certain columns or rows of a table to specific users, thereby controlling access to sensitive data. 3. Reusability. Once a view is created, it can be reused across multiple queries without rewriting the logic. 4. Abstraction. Views can present data in a way that is different from how it is actually stored in the tables. Let's create a view called Employee Department View that joins the Employees and Departments tables. This view will display employee names, their positions, and the department they belong to. Once the view is created, you can query it just like a table. You can fetch data like select statement, SQL view conclusion. SQL views provide a powerful tool for simplifying data access and managing data security. By creating views, you can encapsulate complex queries and provide users with a cleaner, more user-friendly interface for interacting with data. SQL transactions allow us to execute multiple queries as a single unit of work, ensuring that all queries succeed or none do. This is crucial for maintaining data integrity. Let's see how transactions work by transferring a balance between two accounts. This video covers SQL transactions, which are essential for ensuring data integrity when executing multiple queries. The sample code demonstrates a simple transaction involving account balance transfers. Indexes in SQL are used to speed up the retrieval of data by creating a faster access path to the data in a table. Let's create an index on our employees table to optimize searches by name. This video introduces SQL indexes, which are crucial for optimizing query performance. The sample code demonstrates how to create an index on a table to speed up data retrieval. SQL triggers are special types of stored procedures that are automatically executed or fired when certain events occur in the database. Triggers can be used to enforce business rules, validate data, maintain audit trails, and more. Triggers are associated with a table and can be executed before or after specific actions such as insert, update, or delete. Types of triggers: before trigger executes before the triggering action, e.g., before an insert, update, or delete. After trigger executes after the triggering action. Let's create an after insert trigger on the employees table. This trigger will automatically insert a record into an audit log table whenever a new employee is added. The audit log table will track the employee's name, position, and the date of insertion. Step 1. Creating the audit log table. First, create an audit log table to store the audit information. Next, we'll create an after insert trigger on the employees table. After insert on employees, This specifies that the trigger should be fired after a new record is inserted into the employees table. For each row, this ensures that the trigger runs for each row that is inserted. The new keyword refers to the new row being inserted into the employees table. Now, the now function returns the current date and time.